Hey guys, this is Dr. Hub. In case you haven't subscribed, please do subscribe for updates. Let's look into the cholesterol synthesis. So what happens is you have the presence of the acetyl-CoA. Acetyl-CoA, as we know, is a 2-carbon. Then comes the acetoacetyl-CoA. This is 4C, and together it forms the Hmge-CoA synthase. So after Hmge-CoA synthase, there is a Hmge-CoA which is formed, and this is 6-carbon atom. So then comes the presence of the Hmge-CoA. This is the reductase, and this is leading to the mevalonic acid. Mevalonic acid is further, it is leading to the squalene. It leads to the squalene. So mevalonic acid, Hmge-CoA reductase to mevalonic acid to the farnesyl PPI. Farnesyl PPI is about 15 carbon. Then comes this presence of squalene. So you have squalene, then comes the LC, that is a lanosterol, as well as presence of the cholesterol. So the farnesyl PPI is 15 carbon, squalene is 30 carbon, lanosterol 30, and the cholesterol being 27. So next is this cholesterol. It may go to the, it acts on the SAAP and also the SREBP. The SREBP, and it can lead to the synthesis. So ultimately it can lead to the synthesis of the Hmge-CoA, and also the insulin can act on the synthesis, and this is the Hmge-CoA reductase. It is also acted upon by the glucagon, the AMP, as well as presence of the statins. Next is, on the other hand, this Hmge-CoA reductase. There is in this process there is a 2-NADPH, and this 2-NADPH is converted to the CoA and also the 2-NADP plus. So this is nothing but the rate limiting step. To learn and grow daily like this, please do subscribe.